start out with the idea of, if I have 5.2 coulombs of charge, how many electrons is that? Remember, I have to have a whole number of electrons. This is going to be so many electrons, we don't even have to worry about it. We can't get this much accuracy. Now, one electron, we need a conversion factor. We're going from number of electrons. If you need to sit somewhere else, pick a seat anywhere, chairs, all that. We're going from number of electrons to charge. One electron is worth how many coulombs? Coulombs. There's my conversion factor. Okay? There's my conversion factor. Whenever you're dealing with these types of conversions, I recommend using dimensional analysis. Now, all that means is you're setting it up like this. 5.2 times, and this is coulombs, something divided by something. And that's going to come from our conversion factor. Okay? 5.2 times our conversion factor. And you need to decide what needs to be on top and what needs to be on bottom. Right? You want to put what you're going for on top and what you're trying to cancel out on bottom. 1.6 times 10 to the negative 19 coulombs and 1 electron on top. The reason I want to do that, coulombs cancels. Does that make sense? Right? Coulombs cancel. So, how many electrons do I get out of this place? 5.2 divided by 1.6 e to the negative 19. I need a calculator for this. Okay, 3.25 times 10 to the 19 electrons. And that is a whole number, right? Yeah, I know it's 3.2, but it's in scientific notation. Times 10 to the 19th means take that decimal and jump it 19 times to the left. Okay? This is a large number. A large number of electrons makes up coulomb. Okay? Now, let me work another example problem. How many electrons flew past the point if a 3.2 amp current flows for 5.9 seconds. How many electrons? I'm going to give a little negative sign for these electrons, that way we can make sure that we're okay. How many electrons flow past the point if 3.2 amps is allowed to flow 5.9 seconds? Okay? How many electrons actually flow past? What you're going to want to do there? I equals change in charge divided by change in time. That's like velocity equals displacement, change in distance, right? The displacement divided by the time. Okay? I gave you the current, 3.2 amps. We're looking for a charge right now. I give you a time, 5.9 seconds. Let me get rid of that S because we're currently in base units. You tracking with me so far? So now I can get how much charge comes past. WQ equals what? Someone please. 3.2 times 5.9. Now this isn't my final answer, so I'm going to keep all those sig figs. What unit does this have? Coulombs. The base unit for charge is the coulomb. Like, I'm not there yet, right? I've got how many electrons can pass, or I'm looking for how many electrons can pass. Now I need to convert from coulombs to electrons, which is exactly what we've already done. This is 18.88 coulombs times 1 electron has charge of 1.6 times 10 to the negative 19 coulombs. coulombs will cancel, giving me a number of electrons. Okay? I'm using dimensional analysis to keep it straight, what goes on bottom, what goes on top. Okay? Do I divide, do I multiply? How many electrons ended up coming past here? 1.18 times 10 to the 20 E, standing for electrons. Right? Sig figs, 2, 1.2 times 10 to the 20 electrons. Okay. Simple type problem, right? Simple type problem. You good with that? The basic circuit looks something like this. The basic circuit looks something like this. A battery and a resistor. Battery and a resistor. That is a basic circuit. Okay? So if I've got a battery, let's say it's operating at 12 volts. Make that figure be capital. 12 volts. And I measure the current going around the circuit to be 1.5 amps. Right? 1.5 amps. What must be the resistor? What must be the resistance of this resistor here? Now, current does not get used up in the circuit. There is 1.5 amps of current flowing over here. There's 1.5 amps of current here before the resistor. There's 1.5 here, here, all the way around. At every spot on the wire, the current remains the same. What gets used up is the voltage. Now, no voltage can be left over by the time it makes it back around to the battery. Consider the wires to have zero resistance, perfect resistance. That means there was 12 volts before the resistor, and the resistor uses all of it. How many volts are left over? 0 volts afterwards. Okay? This is just a plug shot. What is the resistance? This is Ohm's law. V equals IR. Voltage drop across the resistor. Since it's the only resistor in the circuit, all the voltage drops across it. 12. How much current was flowing through the resistor? The same current that flows through the entire loop, right? 1.5 amps. Now we can solve for resistance R. Without a calculator. Without a calculator. 12 divided by 1.5 is what? How'd you get it? Calculator? Change. Without a calculator. Using some mental tricks. Yeah, you got 1, right? You got 1 of them. You're dividing it by 1.5. Divided by 2 would bring you down to what? 6. But we don't want to go all the way down to 2. We want to go to 1.5. That's half less, right? What's half of 6? 3. Does everyone see where I'm going on this? No, not at all.
And 3 is 1.
Don't use a calculator. Yes, you're going up by 2 now. Okay. Right. 1.5 divided.
It's not really important.
12 divided by, it's not. 12 divided by 1.5 comes out to be 8. Oh, I need more sig figs. 8.0 ohms for 2 sig figs. Any questions over those basic problems? I could give you voltage and current, which you could find from the resistance. I could give you voltage and resistance, and you find the current. Homework. You-